Hello, welcome to Hawk Math. Today we're going to be trying this problem, which is the 1992 AIME problem number 4. Now in this problem, it asks, in which row of Pascal's triangle do 3 consecutive entries occur that are in the ratio of 3 to 4 to 5? Well, let's start by writing out Pascal's triangle, which I've already done for you, or the first few rows, to see if we can see any noticeable pattern. Because if there is a pattern, maybe we can extend it to bigger numbers to find this ratio. Well, looking at these few rows, I don't really see a noticeable pattern in the ratios. We see 1 to 4 to 6, 1 to 3 to 3, and it's not really helping us. We also know that since this is an AIME problem, there's a high chance, since the answer can be any integer from 0 to 999, that this could be in the 100th or so row. So we shouldn't really be trying to write out Pascal's triangle and looking for this ourselves. So what other information do we know? Well, we know that it's going to have to be on the left side of Pascal's triangle if this is even important, because it's an increasing ratio. Well, how else can we write Pascal's triangle numbers such that they're in relation to each other? Well, we know that they're the sum of the two numbers above, but again, that really doesn't help us. We also know that this can be expressed as combinations. So, for example, this number is 0 combination 0, and this one would be 0, 1, 2, 3 combination 2, so that's 3 combination 2, and you can express every number in Pascal's triangle as combinations. So let's just say our answer occurs in the nth row, and this 4 happens at the xth element in that row. Well, then we can write n combination x minus 1 for the term before the middle one over 3 equals n combination x over 4, and that equals n combination x plus 1 over 5. And now we see that we have really two equations. We have this first equation, and we have this second equation. And we see that we have two equations with two unknown variables, n and x. We can solve these pretty easily. So let's first start out by writing out this first equation. So we have n combination x minus 1, which is the same thing as n factorial over x minus 1 factorial times n minus x plus 1 factorial. And we have that over 3, so I'm going to write 3 on the denominator, equals to this part, which is n factorial, over, I'm going to write the 4 first, 4 times x factorial times n minus x factorial. Now, all we need to do is simplify this equation. These n factorials nicely cancel out, and now I'm just going to cross multiply this over here, and then I'm going to bring this 3 over here. So we have x factorial, 4x factorial, times n minus x factorial, over, we have x minus 1 factorial, and then we have n minus x plus 1 factorial, and that's equal to 3. So now we can do some cancellations. We see that if we take this x minus 1 factorial and this x factorial, that cancels out to just an x on the numerator. So 4x, and then we have this part is also going to cancel with this down here, leaving us with just an n minus x plus 1. And that equals a 3. So cross multiplying, we see that 4x equals 3n minus 3x plus 3, or rewriting this, we see that 3n minus 7x equals negative 3. Okay, now that we did this side, let's look at this equation. So we have n combination x, which is the same thing, so I'm just going to rewrite it over here. And then we have n factorial over 5 times x plus 1 factorial times n minus x minus 1 factorial. Okay, so we can write out this equation again by canceling these n factorials to get 5 times x plus 1 factorial times n minus x minus 1 factorial over this 4. I'm going to move to the other side. And we have x factorial times n minus x factorial. Doing some cancellations, we see that we get this and that will just give us an x plus 1. So we have 5 times x plus 1. And then we'll get on this denominator, this will cancel this out, just leaving us with an n minus x, which is equal to 4. Okay, now let's cross multiply. So we have 5x plus 5 equals 4n minus 4x. So rewriting this with a positive n, we see that we get 4n, and then we have minus 9x equals 5. Just going to quickly scan to make sure I didn't make any simple mistakes that could ruin this answer. Doesn't appear so, so now we just need to solve a system of equations. So I'm going to use elimination, so I'm going to multiply this equation by 4. So we get 12n minus 28x equals negative 12, and this equation by 3 to get 12n minus 27x equals 15. Well, if we add these together, subtract, take this, subtract that, we're going to get negative x equals negative 27. And therefore, x equals 27. So now we need to solve for n, because we want to know n, which is the row, and x is where it is. So plugging in 27, I'm going to choose this equation. We see that 3n minus 7 times 27 equals negative 3. 3n equals negative 3 plus 7 times 27 is going to be 140 plus 49, which is 189. So 3n equals 186. So 186 divided by 3 is going to give us 62. So n equals 62. That means our three numbers are 62 combination n minus 1, which was 26, and then 62 combination 27, and 62 combination 28. And those are the specific numbers that are in the ratio 3 to 4 to 5. And so all we wanted was to know which row it was in, which we said was n. So therefore, n is equal to 62 is our answer. So 0, 6, 2. And we are done. Thank you for watching. I really hope you enjoyed this problem. It wasn't too bad once you realize how we can relate these numbers in a way that makes this problem easy for us. So I really hope you enjoyed. Please like the video and subscribe if you want to see more like this.